going to be working on weather systems in Chapter 6. And we're going to be talking about weather systems, meaning frontal precipitation, and then other weather systems of severe weather, particularly tornadoes and hurricanes. But before we can get into those weather systems, I need to introduce you to world air masses. So this is World Air Masses, lecture number 5. And so what is an air mass? By definition, it's a large body of air, a mass of air, with uniform temperature and moisture characteristics. So what happens is, the atmosphere, is sitting over the Earth's surface, and the air, tends to take on the temperature and moisture properties of that surface it's sitting over, and seasonally. I mean, for instance, think of Siberia in wintertime. And so the air is sitting over this landmass, and the air tends to take on the properties of that surface. So what is it like? Siberia, is very cold and dry, so it's going to spawn or create a very cold and dry air mass. Kind of the opposite. Think of maybe the Gulf Caribbean Sea in summertime, and so the air is sitting over this ocean, this warm tropical ocean, and we spawn or create an air mass, and it takes on the properties of that surface. So it's going to be warm temperature, and it's going to have some moisture in it. So anyways, there is a classification system of air masses, and it uses 2 letters. And the first letter is a small letter. And the first letter gives you some idea as to whether the air mass is sitting over an ocean or a continent. And so you use the small letter M to mean a maritime source area, and it'll be a rain producer. And then you use a small c, meaning a continental source area, and it's going to be dry. And then the second letter is a capital letter, and it gives you some idea as to the temperature. A capital A means, Arctic, Antarctic, and polar source area, coming basically from the North or South Pole. And so this is by far the coldest air mass, a bit brutal cold. Now, the next letter is a capital P, and I kind of hate this. It's called polar, but it's not from the poles. It's coming, just south of the Arctic Circle, kind of mid to high latitude location. So not, 66.5 degrees, but maybe 50 to 60 degrees, something like that. And so P is called polar. It's not from the poles, but it's definitely a cold air mass. Now we'll get this straightened out, in my discussion. And then we take a big jump on down, tropical source area. And so that's going to spawn a warm air mass, relatively speaking. And then E, a capital E, means an equatorial source area. So that's going to be the warmest. So what we're going to do is we're going to put these letters together. And we're going to see that there are 6 air masses that are found on Earth. And so I'm going to do a table, the properties of air masses, and we're going to list the 6 air masses. Now what we're going to do is begin with the classification, the letter classification, and then we'll almost restate what the letter classification is saying by noting the source area. We're going to give you the average, temperature of the air mass, during the seasons, and then we're going to give you the average water vapor content in grams per kilogram, and we'll just go by comparison. All right. And then we're going to mention whether it tends to be stable, being dry, or unstable, right, being a rain producer. So let's start with the first one. The first one is called maritime equatorial. So on the exam, you're just going to see the letters, so you're going to need to be able to read it. Maritime equatorial. And like I said, the second column, it's almost redundant because this is what it's saying. It's oceans near the equator. All right, oceans near the equator. This is by far the warmest air mass. And, 81 as an average temperature is very, very warm. Seasonally, and the temperature in the troposphere and what have you. So it's very, very warm. and very moist. It's very, very humid. And so warm air can hold a lot of moisture. And this is definitely the most unstable. It's a big rain producer. This is the air mass that brings all of that rain, yeah, associated with the equatorial low pressure belt, and the intertropical convergence, bringing tremendous amounts of rain to the equatorial region. Now, the second one is an important one. And so there are two that are going to be starred as important. Actually, this one is double starred, super important. How do we say it? It's maritime tropical. Maritime tropical. So, restating it again, it's oceans near the tropics. And, why do I have this not just starred, it's double starred? I mean, this is our air mass. Right, this is the air mass that dominates Louisiana and the southeastern United States. I mean, it dominates our weather all summer long, all right, and probably maybe up to about a third of winter time. So this is definitely, we own this air mass. It really dominates. So we're going to be working with maritime tropical air. All right, and so the average temperature is 75 degrees. And again, you think about, that's a warm temperature considering, summer and winter temperatures. So it's still warm. And, it's definitely got an ocean source area and it's warm. So it can hold a lot of moisture. And just think about it. When we're dominated by maritime tropical air, it's definitely unstable. It's going to be warm and humid with clouds and produce precipitation. All right. And so this is the air mass that creates all of our convectional precipitation in summertime. All right. Yeah, so at the same latitude, tropical location, but now over land. And so let's kind of maybe move westward and think of the deserts of the southwestern United States. So it's called continental tropical. And so this is the air mass that creates the great deserts of the world, the subtropical high deserts, like the Sahara and Australia and things like that. The average temperature of this air mass is 75 degrees, and that might be kind of surprising when you think about, oh my God, Phoenix is 110 or whatever. But the thing is, it's the average. If you think about the daily high, it's very, very hot, but the daily lows are quite cool, and it's because it's a cloud-free environment. And so being cloud-free allows the air to heat up tremendously, but at night, all of that long-wave radiation escapes to space, and so you have excessive chilling and surprisingly cool temperatures at night. And so those cool temperatures at night bring down the average. All right. And so the other thing, too, is for being a desert, 11 grams of water vapor seems like a lot. But remember, due to a lot of heating, right? What is heating, due to relative humidity? Because of a lot of excessive heating during the day, right? That tends to keep relative humidities low, right? Low relative humidities. And so it's definitely dry. It's definitely stable, right? Because relative humidities tend to be low because of excessive heating. All right, maritime polar. Right, this is where we're going to get polar straits. So this is not coming from the poles. It's coming from mid to high latitude locations. And it's a maritime source area, so it's going to be the oceans. So this would be like the North Pacific or North Atlantic, right, for our area. And surprisingly, I mean, the temperature is quite cold, but again, we're talking about 50, 60 degrees, latitude, so it is quite cold. And it's a pretty big rain producer. It's definitely unstable. And again, here's this number that's kind of surprising. For being such a, big rain producer, it's not really holding that much moisture. But again, it's kind of the opposite of what I just stated with excessive heating. Because of a lot of chilling of the air, right? When you cool air, that increases relative humidity. So because of a lot of chilling of the air, relative humidities tend to be high. And so it's definitely unstable. And this is the air mass, if we're thinking about the Pacific Northwest, this is the air mass that comes in from the North Pacific and brings up all that abundant orographic precipitation to Seattle and Portland and Northern California. So it is a pretty big rain producer. The fifth one is another one. I've got that one starred. It's called continental polar. And again, polar is coming from mid to high latitude locations. And C means continents. I've got this starred because we're going to be working with it. Since I've got it starred, I'll give you the example. I mean, it's coming from Canada. Canada is the source area. And the average temperature is quite cold. I mean, Canada gets very, very cold in wintertime. And so you kind of average it on out. It's kind of surprisingly cold. And, it's coming from a continent, so it's going to be dry. And again, cold air can't really hold much moisture, so it's going to be stable. So a lot of times in wintertime, we get continental polar air, coming behind a cold front, bringing Canadian air. And so it's definitely, once the cold front moves through, we get that Canadian high pressure, and it's cold and dry for us. And the final air mass is called continental Arctic, or in the southern hemisphere, continental Antarctic. And so this is, the air mass that comes from the poles, above the Arctic or Antarctic Circle. And it is by far the coldest air mass. This is the average temperature, all right? So minus 51 degrees, is the average temperature at the poles. And it's very, very dry. I mean, cold air definitely can't hold much moisture. So it is definitely the most stable, right? And actually, sometimes we get continental Arctic air in the winter. Not every winter, but sometimes, we'll get it, every few winters. And we get continental Arctic air when we get well below freezing temperatures. Usually kind of record-breaking temperatures in the teens or 20s. And so we don't get it every year, but we do get continental Arctic air, in some winters. So there is actually a pattern. I mean, if you've got an ocean source area, just kind of note. I mean, it's always going to be a rain producer. That's the pattern. And then if it's a continental source area, it's always going to be dry and stable. So that's kind of an easy thing. Now on the test, I would never ask you these numbers. You don't need to really worry about that. But you just kind of need to be able to read them and know the source areas. And our next lecture is going to be on frontal systems. And what a front is a boundary between opposite air masses. And we're going to be working with these two opposite air masses. Air mass coming from the Gulf of Mexico, moving northward in the United States, meeting air coming down from Canada that's cold and dry. And so that's why I've got these starred, because you're going to see maritime tropical and continental polar air masses battling, in the United States. Creating frontal precipitation. All right. Here's a map of North America showing the source area of continental polar air way up in northern Canada. And up there in the source area, it's minus 50 degrees. So, it's very, very cold. This would be in winter time. Right. And what winds up happening is, air masses are spawned or created in a source area, and then they tend to move out of their source area, and they can become modified. And so this can move in wintertime behind a cold front and move southward, and eventually it can make its way to, to us here in the Gulf region. And certainly, that air mass, once the cold front moves through, it's not going to be 50 below zero, but it's going to bring cold temperatures to us. I mean, 40s or 30s or maybe even the 20s as is illustrated here. So since that air mass is moving southward, it's going to warm up and become modified. So air masses can change or modify, but still, in this case, it would be cold for us. Here's a map showing, all the air masses that affect North America, and so the source area, and then they've got arrows showing, where they tend to move out of their source area and affect other regions to become modified. Like here's, maritime tropical, basically our air mass, so it kind of moves out of its source area, kind of northward, and it becomes modified, it moves northward, and believe it or not, it kind of dries out, right? And we get the full moisture content. It's very humid for us. But when it moves northward, it's still very humid for those northerners. I mean, but for us, if we get it, it's nothing to us. We're used to it. And so that's a big one. And then what we're going to do is have it meeting in the United States, and it's going to battle, as a frontal boundary, either with continental polar air, coming from mid to high latitude locations like Canada. It'll move out of its source area, particularly in wintertime, and meet maritime tropical. Or then sometimes, you get very, very cold air coming from the, North Pole, or, Arctic Circle, continental Arctic, and it can sometimes, bring very, very cold conditions to us. All right, and then maritime tropical is also in, like the South Pacific. Now, in terms of the United States, it's not really as dominant as the one that comes from the Caribbean. It'll bring in a little bit of moisture to, California. Bring in a little moisture to the desert Southwest, but it's really not as dominant as the Gulf Caribbean one. Maritime polar, right? This is the air mass. It's really most dominant in the North Pacific. Moves in the westerly winds and brings in abundant moisture, and it's blocked by the high mountains. And so this is the air mass, of orographic precipitation, bringing, a lot of rain to Seattle and Portland and Northern California. The maritime polar of the North Atlantic isn't quite as dominant as the one for us in the United States. It tends to move in the westerly winds and really dominates more of Europe, all right? But it does affect, the New England states a little bit. So these are the air masses that affect North America. The only one that really doesn't affect us is maritime equatorial. I mean, we're just too much of a mid-latitude location or even tropical location, so we don't get any equatorial air. Oh, end that lecture.